Let's examine this conveyor belt problem. So I have a box sitting on a conveyor, and I have a part here that I call push rib, and inside of that I also have a roller that I'll use to move this rib along the belt, and then a couple of rollers for the belt. Now these are just for show, but the idea is then to push this box along the belt, and then when it reaches to the end, gravity will take over. I did a couple of settings here that on this box to this part I did tangent. That gives me a single line of contact along this box, where if another strategy is if I just had a flat face, it would be an infinite number of points of contacts along this face to the face of the box, where this was one line of contact, but again that's an infinite number of points. I might have put a spherical surface over here and done a tangent between that spherical face and the box, and then that would be only one line of contact. I also then, for the box, I have that setting off of the belt 0.1 millimeters. I may change that to 0, but initially, so it's not in contact, so gravity will take over and it will fall initially. Now I may change that to 0. Now these are home positions that I suppress those. That centers the box and puts it up against this rib and offset just a bit from the belt. I'll then go to dynamic simulation, and the first thing I'm going to do is define gravity. So I'll set my gravity, and I want that to be going in the negative y direction. And if I don't know that I have anything in here to select, so I'll do this as vector components, and I'll do in the negative y direction. I need to change that, so let's edit that. I thought that I had put in the negative. I must have missed it. Alright, so now my gravity is pointing in the right direction. So I have a planar joint for the box, and then I have a prismatic joint as well, but this is for welded group here, and I see that the box is in the mobile group, but these two rollers are not in the mobile group, and also I see that this push rib and the motivation dummy roller are welded together. I want to separate these two parts, so I'm going to right click and I'll say retain degree of freedom on that, and it puts that into the mobile groups with a revolution joint. I'm going to do the same thing with these two rollers. So they have insert constraints on them. I'm going to tell it retain degree of freedom on that one, and I'll retain degree of freedom on this one. Now everything is in the mobile groups except for the belt itself. So this is going to be a little bit of a fudge where we'll simulate the belt moving, but the belt doesn't actually move. And so then I'm going to do a 3D contact between the box and this component, and between the box and the belt. So I'll insert joint, and I'll do 3D contact, and I'll select the box, and I'll select the belt, and I'll also select this component, and I'll select the box. It doesn't really matter where we pick it. And then I'm going to do a belt joint between these two rollers. Now we don't really need the belt joint, but that will make these rollers appear to be pushing the box. And so I'll do an insert joint, I'll do a belt joint, and so I want that to be a straight belt. I'll select the first cylinder, I'll select the major diameter of the first cylinder, and for the second cylinder I'll select the major diameter of the second cylinder, and I'll say OK to those. Alright, then I want to rotate these two cylinders together, so I'll find a revolution joint for one of these cylinders, and so I'll go to the properties of that, and I'll go to degrees of freedom 1 revolution. We'll do impose motion, and I'm going to do a constant value. Let's start out with 360 degrees per second. Alright, I also want to move this part, or have this part rotate. And let's see what we have so far though before we do that. And so I'm going to go ahead and run this, and we see with the belt joint and the revolution joint on this that these two rollers turn. I'm then going to turn this revolution joint, so I need to find that revolution joint. I'm going to go to the properties of that, and 1 degree of freedom rotation, and I'm going to put in a constant velocity or value for that. And we can set this thing up where the circumference of this roller is matched to this circumference of this roller with just the right degrees of motion per second. But initially I'm just going to put in some numbers, so I'll just do 3. Let's go higher than that. Let's go 720 degrees per second on that roller. Alright, then I'm going to do a rolling cylinders on curve. So I want this cylinder to roll along this curve. So I'll insert joint and I'll do rolling cylinder curve. So it asks me to select the curve first. I'll select this edge on that face, but it has 2 edges. It has an edge up here and an edge here. Of course I want this edge up here. And then I'll do this cylinder. I'll select the major diameter of the cylinder, and if I want to move this origin out here, I could select this circle to move the origin out there so that it's lined up with that edge. I'll say OK to that. Now I see that I get an overconstrained condition, which I'm going to need to solve. If I expand the joints and examine the constraints, I see that I have a mate constraint between the bottom of the push rib and this planar face on the belt. Of course, when this comes around and starts to go around, that can't stay mated to this face. And so I'm going to right click on that constraint. I'm going to suppress that constraint, and that got rid of our overconstrained condition. Let's try to run this and see if it works. Alright, so we see that it is starting to move the box, but our motion isn't correct, so we need to make some adjustments. If I zoom in here, so as we were starting the motion, this part was not staying on top of the belt. If I play it, and once the motion starts, we see that it falls over. So we need to keep either this corner or this corner along this edge. Now the cylinder will stay. We already set the rolling cylinder on curve, so that will stay. So we just need a second point. And so I'm going to insert joint. I'm going to do a sliding point curve. First I'll select the curve. I need to select the edge because there's an inside and outside edge. I need the outside edge. And then for the point, I could either select this point over here or this point over here. I'm going to select this point. We'll say OK to that. I'll save it, and this time when we play it, and I increased my time to 10 seconds, and when I play this, then we see that this roller starts rolling along that curve. This point stays on that curve, and it's pushing our belt. Now we may want to increase the revolutions on the drive roller, and so I'm going to stop that, and we'll rewind, and we'll increase that. And so let's go to that revolution joint. Instead of 720, I'm going to do 1440. We might even increase it beyond that. Now notice as we play this, and I'm going to play say every 5th slide, there starts to become separation between the pusher and the box. So we need to get the 3D contact joint set up correctly, that we don't get that large separation between these two components. So after setting friction in the 3D contact between the box and the belt, and between the push bar and the belt, and setting a dampening value so that it stays up against, or close to staying up against, the push rod, and I think I have everything working now. So let's go ahead and play this. I'll put it down to every slide, and I'll play it forward. And so we see that it pushes the belt. Now if we wanted to, we could hide these two components. Those are necessary in order to get the box to move, but maybe those are just dummy components that we don't really want to be visible, and so we could hide those components. And also maybe we could go to shaded rather than shaded with edges to hide this line and this line back here at those tangent points. And we see that as it approaches the edge, it has to do more calculations, and it slows down. But if we publish this to Studio, then we can run it at any speed that we would like. Once it has been solved, we could then publish this motion to Studio. So we calculated 1,000 positions or 1,000 slides. Of course, each one of those slides would play back at the same speed in Studio rather than slowing down here when it got to the edge of the belt. Here I've published my simulation to Studio, and so we can play this and we see that everything plays smoothly, and I can actually look at something in reverse order. And if I want to turn off the visibility of these two components, so I could turn off the visibility of that component and turn off the visibility of this component, and we'll play that again. And so I can then adjust that motion to occur at any time period that I would like. So if I want to decrease that time period, and we'll play it again. And of course we would want to set up the timing of these rollers to match the motion.